Yeah, that's always fun.
Yeah, but at least I upgraded to a nicer phone. So what do we got tonight?
I'm looking. Um, Hold on, it's loading up. I'm checking. So this one is expressed in the terms of I, and it's the square root of -5.
All right.
You have to,
Mm-hmm. No, I know.
yeah.
The first thing to recognize is that the square root of a times b is the square root of a times the square root of b. All right?
Okay.
Which makes, when you have the square root of a negative number, first thing you do is take out the -1. That leaves that left over.
Okay.
And
That makes
that
sense.
answer is the square root of 5 times I. In other words, that is I.
The square root of 5, or -1.
The square root of -1 is what I is. And
The
so
square root of -1 is what I is. Okay.
that's always I. That's I right there. So that's why I separate it out as my first step, because now I know exactly what I is, and whatever's left over, I deal with that. But it's based on that concept. If I say, what
Okay.
is the square root of 12? Well, that's equal to the square root of 4 times the square root of 3. So you can always separate square roots into two factors.
Okay, that makes sense.
In this case, whenever you're dealing with a negative number, always take the -1 out, and then it becomes an easy problem.
Alrighty.
Okay, what else?
So, but it says type your answer in the form of a plus bi.
Okay,
Is that just what
so,
that is there?
well, that is standard format. Okay, now
Okay.
what we got was square root of 5i, right?
Yeah.
Well, that is 0 plus square root of 5i. Now you don't have to write the 0 in, you don't have to write the plus sign in. So you can write that much and it'll be correct. Just
So
make
this is 5i pretty much.
sure the I is outside the radical sign, not inside it.
Yeah. So is it just the square root of 5i then?
Uh-huh.
Okay. So square root of 5i.
Now, this is the standard format for a complex number, a plus bi. And usually there's an a. It's just that in this case, a is 0.
Okay. And this one says express in terms of I. And it says express the complex numbers in terms of I, and it's negative this negative square root of -2.
Negative square root of -2. Okay, so what should we do with that?
Take the -1 out. So
Tell
we
me
have a
what to
square root of
write.
-1.
Okay,
Huh?
okay, what else?
And then we have a square root of 2.
All right, now what does that give us for an answer?
Would that give us 2i?
Don't forget that negative.
-2.
Do
Yeah,
not
it
drop
would be negative the square root of 2i.
negative square root of 2, and I is outside. Notice that in the standard format, B is a real number, and I is always outside of that. So you never want
Oh,
that I to be inside the radical sign.
alright, that makes sense.
Okay? What
So
else?
it's a negative square root of 2i, correct?
Yep.
Okay. Alright, the next one is loading. The square root of -8. Is that just 8i? The square root of 8i?
Well, not quite. I mean, you're close. It is that, but that's not simplified. Because
Okay.
square root of 8 is what?
It's 2, isn't it? Or 4, I mean. Goddamn.
Okay, what you're trying to do to determine whether you can simplify that or not. Are
Okay.
there
This one has to be written
are
in
there any
standard.
factors of 8 where one of
2 and
the
4.
factors is a perfect square number?
4.
Exactly. So that's the square root of 4 times the square root of 2i, and the square root of 4 is a whole number, so you can take it out.
Okay.
So that's the final
And
answer.
and then we have to write it in the standard form too. Is that this final answer? The standard,
Well,
that standard right there?
notice that, yeah, in other words, that's 0 plus 2 root 2i. That is a
Okay.
coefficient right there. That's not two different numbers. That's not A and B. That's B.
Okay.
A typical complex number might be this, 2 plus 3i. That's different. In this complex number, 2 is the real part of the answer. 3i is the imaginary part.
Okay.
So far, everything they've given us doesn't have an A to it, just has a B and an I.
That makes sense.
Betting we'll get one though.
So the next one is add and simplify and write the answer in AB or A plus BI, and it's parentheses -4 plus 9i, and then plus parentheses 6 plus 7i.
Adding, subtracting, multiplying are all exactly as you think it would be.
So would it just be 2 plus 16i?
Uh-huh. Now, if we were
Okay.
to subtract those, it would be minus 10 plus 2i.
Okay.
If we were to multiply those, I would FOIL it. So I would have minus 24 minus 28i plus 54i. And notice what the last term is, 63i squared. Well, I can definitely combine those middle terms, but I squared is equal to what? If I equals the square root of -1, what does I squared equal?
2 or
-1.
wait.
In
Okay,
other
yeah, that
words, if
makes
you
sense.
take the square root of -1 and you multiply it by itself, you get -1. And that's
Okay.
very important to know what I squared is, because you frequently have to convert it. In other words, for me to simplify this, it's going to be minus 24. These two become plus 26i. And then this becomes minus 63 because it's 63 times a minus 1. And now if I combine the numbers to get A, I get minus 87, combining that and that, plus 26i. That is your answer in A plus BI format. There's A,
Okay. Where did
there's B, there's I.
all right. So I'm a little confused where like the subtraction stuff came from.
Subtraction is the
Because
same
like,
as addition. In other words, I'm going to
well,
take
yeah, but
minus 4 minus 6. That gives me minus 10. And then I'm
why
going
don't
to
we
do
use that instead of
9i
addition?
minus 7i. And that's plus 2i.
Okay.
Multiplication is all I did was FOIL the two terms. In other words, every term by every term. I multiply that by
Yeah,
that,
yeah.
multiply that by that, multiply that by that, multiply that by that. The only confusing part is that last term, which is in our case 63I squared. Well, I squared is a real number. It's -1. It's no longer an imaginary number. So you can always convert I squareds to -1, and you will need to do so frequently.
Okay, so do you go from like addition to subtraction to multiplication? Is that like an important step or like?
The only reason I mention those three is those are the really easy ones.
Okay.
The only one that is hard is division.
All right.
Now, let's talk about why that's hard. What do we have? We have, let's say I want to divide them. Not really a division problem. Looks like one, but it isn't. Okay, here, let me write this a little bit better. If I wanted to divide those two things, that's the way I would write it, but I wouldn't do it as a division problem. Any more than I wouldn't do 1 over square root of 2. That's not a division problem either. That is, rationalize the denominator problem. So you get square root of 2 over 2, right? So you're familiar with that concept.
Kinda, yeah.
Okay, well, let's go over it if you're not familiar with it, because it's certainly the bigger part of algebra than complex numbers are. If you have an irrational number in your denominator, you have to rationalize it so that you end up with a rational number in your denominator. So 1 over square root of 2 becomes square root of 2 over 2, which is fine. The irrational number is in the numerator with square root of 2 over 2. As long as it's not in the denominator, you're fine. Okay? So that rule applies to irrational denominators. Well, a similar rule applies to complex denominators. What I want to do to get rid of the complex denominator is multiply it by its conjugate, 6 minus 7i. And since I can only multiply this fraction by the number 1, there's my number 1, what happens is it gets rid of the imaginary denominator. Notice that when I multiply the denominators, I get 36 minus a 49i squared, which becomes 85.
Okay.
In other words, whenever you multiply an imaginary number, a complex number, by its conjugate, it turns into a real number. So,
Okay.
as long as I multiply the bottom by 6 minus 7i, then I got to multiply the top by 6 minus 7i. The only thing you're allowed to do with a fraction is multiply it by 1. Well, when I multiply the top, I get minus 24 plus 28i plus 54i minus 63i squared. Now, let's look at the denominator. The denominator becomes 85. Perfect. That's a real number. It's no longer a complex number. Now, I'm going to combine those two terms to give me plus 82i. And then I'm going to combine that term and that term. Well, that term
Wait, did you FOIL the top?
that term's plus 63. So the net of the numbers is 39.
Okay. Did you FOIL the top part?
I did. In other words, I
Okay.
FOILed that with that.
Why isn't the bottom FOILed? Is that because it's the same?
It is FOILed. It's just that when you FOIL a binomial with its conjugate, the middle terms disappear, always. And you end up with, notice that that's the difference of perfect squares, and that's the difference of perfect squares factored. And
Okay.
that's why they focus so much on the difference of perfect squares. It's because it comes into play a lot. You not only want to recognize difference of perfect squares, you want to recognize it when it's in factored form. And it's in factored form when I'm multiplying by the conjugate. So I don't have to go through it. If I were to go through it, it would be 36 minus 42i plus 42i minus 49i squared. Well, these two always cancel, always, when you are multiplying something by its conjugate. So what you're left with is the 36 minus 49i squared. I squared is minus 1, gives you 85.
That makes sense.
Now the numerator
So if you're multiplying something by its conjugate, it cancels out, correct?
cancels out the middle two terms that you would typically get.
Okay.
In this case, that's what turns the complex denominator into a real denominator, is by multiplying by its conjugate. In the same way that when I have 1 over square root of 2 up here on the left, that's not a division problem. What it is I'm going to multiply by square root of 2 over square root of 2, which is the number 1, and that turns the bottom into a rational number. It's okay to
Alrighty.
have rational denominators. It's not okay to have irrational denominators. Square root of 2 is an irrational denominator. Same thing with complex numbers. It's not okay to have a complex denominator. It is okay to have a complex numerator. Now, I'm not quite done. That's not my final answer. Remember what they want the answer in is a plus bi. So how do I turn that answer that I have, this one right here, into a plus bi? Got to split it up into two fractions.
Yeah.
39
Okay.
over 85 plus 82 over 85i. Now it is in a plus bi. A is 39 over 85. B is 82 over 85, and there's your I. And this is always what you're going to be looking at, is in the format of the middle circle on the right. That's always the kind of answer you're going to get when you do a division problem.
Okay. That makes sense.
So you always,
So,
if they want the answer in standard format, then you always have to split that into two fractions. That fraction there and that fraction there.
alrighty. So, what was the a plus b answer for the original problem?
Well, we didn't have
Do you
any
know?
A's.
We didn't have a what?
We did not have any A's. In other words,
Okay.
here, hold on, let me get it. I got it here. Here's the original problem. We had minus 4 plus 9i plus 6 plus 7i. When we added those together, that was our answer. I'm sorry, we did have an A. 2 is A.
So it's 2 plus,
Plus 16i. A
okay.
is 2, B is 16, there's the I.
Alrighty.
Adding is very simple. You just add the real parts and you add the imaginary parts separately.
That makes sense.
There's fewer things simpler than adding complex numbers. Same thing with subtraction. You subtract the real parts and you subtract the imaginary parts. Multiplication is foiling. So addition, subtraction, and multiplication are exactly what you would think they would be. The only thing you have to remember with multiplication is that you can convert the I squared to -1.
Okay.
The only thing that's a little weird is division, because it's not really division. You notice
Yeah.
that I didn't divide anything. I did nothing but multiplication. I multiplied
That makes sense
the
though.
bottom by the conjugate, and I multiplied the top by the conjugate. And I did
So
nothing but
you
multiplication. I did no division at all.
so you multiply the top and bottom by the conjugate, right?
Exactly.
Okay. So
Now,
the next
let me just test you. Let me give you a little bit of a strange one.
okay.
What's that?
Would you multiply it by I over I?
Well, that actually works. But if you were multiplying by the conjugate, you'd multiply by minus I over minus I.
Okay, that's right, that's right.
And the reason that works a little bit better is because that puts minus I squared in the bottom, which is 1.
Okay.
And the top becomes minus 5I. So the answer becomes minus 5I. Now, you could actually get away with multiplying it by I over I, but that gives you I squared, which then converts to minus 1 and introduces additional negative numbers, which you don't particularly want. So that's why that's the conjugate of I, is minus I. In other words, think of I as being 0 plus I. Well, the conjugate of
Okay.
0 plus I is 0 minus I. So what's the
All
next?
right, I got that now.
Okay, what's the next one?
The next one we have is parentheses 9 plus the square root of -4 plus 3 plus, or no, it's plus parentheses 3 plus the square root of -64.
All right.
Okay.
Well, the best thing to do here is
It says to
to,
add.
no, is to convert each one to a complex number.
Okay.
Because I don't know how to add square root of -4 to the square root of -64. But once I
Okay.
convert it to a complex number, I will. So what is the square root of -4 equal to?
-2, right? Or is it just 2?
Always remember how
Is
to,
it
always remember how to do it. Take out the -1 first. What else does that leave?
2?
Well, square root of 4,
Square root, yeah, my bad. My
which
bad.
is 2.
2. That's 2 now.
So that's
Okay.
it,
Okay.
is 2I.
All right.
Okay, what?
So
And then hold on. Let's convert this. What is the square root of -64?
would that be the square root of -1 and the square root of 8,
Not the
which
square root of 8,
equals,
but the square root of 64, which is 8.
oh, yeah, which is 8. So it's 8i.
Correct.
So it's
Now, adding them is a piece of cake. What's the answer?
just 12 plus 10i.
Uh-huh.
Okay. And then that's an A plus bi form, right?
Definitely,
A
it's
sim
definitely A plus BI. There's A, there's B, there's I.
twelve.
What would not be A plus BI is if you had something like 8 plus 4I all over 2. That is not A plus BI format. You would need to separate that into two parts. There's the A, which is 4, and that becomes 2I. So that would be 4 plus 2I.
Alrighty.
Okay.
So the next one we have, are you ready? Yeah. The next one we have is subtract and simplify, parentheses 12 plus 8i minus 9 plus 4i.
Now, you don't need to worry necessarily about removing the parentheses like you typically would.
Yeah.
Is all you need to do is subtract the real parts and subtract the imaginary parts. What do you get?
So we'd get 3 plus 4i.
That easy.
Yeah, these are pretty simple when you know how to do them.
Yes, they are. Addition, subtraction, and multiplication are very simple. Although we should do a multiplication one to make sure you know how to do it.
I'm pretty sure one's going to come up. There's still a lot left in this assignment.
Okay, go ahead.
Just a second. I'm just working through them in order. See.
That's fine.
Yeah, here's a multiply one right here.
Okay.
It says multiply parentheses square root of negative 9 multiplied by the square root of negative 36. And then we have to put it in the I form, right?
Okay.
So would we take negative 1 out of 9?
Let's convert each one to an imaginary number. That's the best way to do it.
Okay.
And there's a reason for that. There is a problem with this answer. And I'll show you what it is. But the solution is to always convert to an imaginary number. Don't leave it as a radical of a negative number. So let's move the square root of minus 9.
All right, so would we take negative 1 square root of 1 out? Yeah.
Okay. So yeah,
and then,
that's equal to the square root of negative 1 times the square root of 9. What's that equal to?
3i.
Good. Now we're multiplying that. What is?
By 6i.
What do you get?
Oh, geez. That's 18, right? 18i.
I squared, which is equal to what?
18i squared.
Yeah, you got to multiply this 3 times this.
Okay.
You got to multiply the I times the I also. So you get I squared. You're going to run into this I squared a lot. You need to know what to do with it. It turns into a negative.
Okay. So is the 18 is squared too, right?
Nope.
No, so it's just
I got
18i squared
by
then?
multiplying 3 times 6.
Okay.
I got I squared by multiplying I times I.
Oh, so is this like a FOIL thing then? Or no?
Not really. When you have 4 terms multiplied together, you got to multiply them all.
Okay, that makes sense.
I got a 3i times a 6i. So I got to multiply the 3 times the 6 and the I times the I. I could multiply the 3 times the I and the 6 times the I, but not really. In other words, when you have A times B times C times D, you just multiply them all once. Multiply that by that, take your result, multiply it by that, take your result, multiply it by that. Or I can multiply A times B first, multiply C times D first, and then multiply that result by that result. But one way or the other, you got to multiply all 4 things. So I multiply 3 times the 6 to get 18, and the I times the I to get I squared. Well, that's equal to what? What real number?
18 squared.
No. What's I squared equal to?
Negative 1, right?
So that's negative 18.
Okay.
In other words, that's the same as 18 times negative 1, which is negative 18.
So it's negative 18 is the answer?
Uh-huh. However,
okay.
If we go back to the original problem, and one were to say, Well, we got the square root of a times the square root of b equals the square root of a times b. Well, if I do that with this problem, I get the square root of 334, a positive 334, which gives me a positive 18. So you got to be really careful here. There's some rules of math that you cannot apply when you're dealing with complex numbers. And one of them is this rule right here, one I just circled. You can't
Okay.
multiply those two numbers together, turn them into a positive, and then take the square root of 334. That's not correct. That's not the way to do it. What you have to do is convert each one to a complex number, 3i times 6i. Then when you multiply everything together, you actually get minus 18, a completely different number. So
Oh, okay. That makes more sense.
just remember, you always have to convert it to a complex number first, not last.
Alrighty.
All right, what else you got?
Okay. Next one we have is multiply 3 parentheses 5 minus 5i. And then simplify in the form of the standard formula.
Okay, this is just a distribution. Distribute
So
the
we get
3.
15 minus 15i.
No,
No, it's 15i.
that's in the answer, and it's in A plus BI format.
Oh, so that's it? It says 15
Uh-huh.
plus minus 15i. Okay.
All you're doing is distributing the 3 to there, and then distributing the 3 to there.
Okay, that makes sense. Let me go to the next one real quick.
Okay.
Just a second.
I'm pretty impressed that you got a phone that you can do GoToMeeting on at the same time you can be logged in to your website that's giving you these problems. It just
The answer is,
shows you how
oh
powerful
yeah,
phones are.
yeah, they're pretty crazy nowadays. So it's 15 minus 15i, correct?
Uh-huh.
Okay.
You think, is that what we had? Yeah.
Yeah. Oopsies. What's going on with the site? It is a little hard to maneuver on the
Oh yeah,
phone though.
sure. I can't even imagine it. I can't even hardly use a virtual keyboard on my cell phone. And I don't have fat fingers. I got skinny fingers. I still can't do it without.
I have huge fingers, so it's like really hard for me sometimes.
Oh yeah, it's hard. Especially since the sweet spot isn't generally directly over top of the letter. It's generally some distance away. You know what I mean?
Yeah, right? I know what you mean.
Mhm.
It says that's wrong, by the way.
Well, tell me the problem again.
Three, oh, see, okay, I couldn't see. There's 3i on it. The 3 is 3i, not just 3 alone.
Okay, well that's going to make a huge difference, right?
Yeah, yeah.
Okay, so this was the problem.
Okay. hmm
Okay,
Sorry, I couldn't see it. I think I need
distribute both
glasses.
of them. Now what do you get?
So we get 15i minus 15i squared.
Now convert the I squared and you'll end up with a real number.
Convert the I squared.
Mm-hmm.
So do we just get positive 15? Yeah.
Hold on, just convert the I squared for the moment.
Okay, the I squared is negative, right?
-1.
-1.
Okay.
So a negative times a negative is a positive.
So that puts the number, the A part, as positive 15 plus
So we have
15I.
So we have 15i plus 15i, or
Oh,
15 plus 15i.
15
Okay.
plus 15I. This always
Okay.
has to be the real number. This is the coefficient of the imaginary number, but it's a real number also. But the final answer in a plus bi format is 15 plus 15i. Notice that this term here went to the front. That's that term right there. The 15i, I just moved it to the right side.
Okay. Yeah, that was right. Okay, the next problem is parentheses 3 plus 4i times parentheses 8 minus 5i.
Okay, do this.
Is this some
foil it.
Like foil? Okay, so
whenever
we
you
get
are
3 times.
multiplying a binomial term times another binomial term, you always just foil it. If you're multiplying a binomial times a trinomial, then multiply every term by every term, which is the same as FOIL. FOIL is just every term by every term. So what's the first term?
So we have 3 and 8.
Multiply them.
That multiply, yeah, multiply. I'm totally spaced. That's 24, right? 3 and 8.
You don't
Okay,
know
so we
that.
have 24.
Your calculator in front of you at all times.
No, I have it in front of me. I'm a little tired right now. My mental.
Okay. What's the next term?
And then we have hold on, something's going on in my house. And then we have negative 15i.
Okay. What's the next term?
And then we have 4 times 8, which is 4 times 8 is 32i.
Okay.
And then negative 20i.
Negative 20i squared.
I squared, yeah.
Pesky I squared again. That's actually not pesky. That means you can convert that to a real number. So you love it when you see an I squared. You can't do anything with i's, but you can do a lot with I squareds. They turn into real numbers. So tell me what that converts to, simplifies to. Let's start there.
That just So 24, we have the negative 15 and the 32i go down to 17i.
Plus 17i. You need the plus sign.
And then, yeah, and then that one is 20.
Plus 20.
Plus 20, yes.
Now combine the reals.
We have 44 plus 17i.
And that's in A plus BI format.
44 plus 17i. Okay. Just a minute, I'm just checking. 44 plus 17i, yeah? 17i. Good, that was right.
Okay.
Next one we have...
The only ones that are hard are division ones. Adding is easy, subtracting is easy, multiplying is easy, as long as you know what to do with I squared. The
next one we have
division.
The divisions are hard, but I'm sure I can figure them out.
If you have a division, let's do a few of them. Because those are the only ones that are really going to give you any trouble.
Okay. Are you writing some out? I'm trying to. I can't see which ones are like there yet. So.
Oh yeah. Okay. I forgot. You can't look ahead. Well, let's just go in order.
Okay.
No, I see you've got some more sessions scheduled, so we'll definitely get.
Yeah, we can.
We'll get to the division ones for sure.
I'm pretty sure we might be able to finish this lesson tonight. So.
All right.
There's only 5 questions left. So. This one is parentheses 3 plus the square root of negative 25 times parentheses 7 plus the square root of negative 49.
Okay, what's first step?
Fix the square roots
to
be real numbers, right?
No, to be imaginary numbers.
Imaginary numbers, yeah, that's right.
Both
So,
square root of a negative number. That means it's an imaginary number.
okay. Would we get 3 plus 5i? Negative 5i, that is?
No, 3 plus 5i.
Okay. And then 7
Hold on,
plus.
hold on. Let's back up.
Okay.
Minus.
I understand why.
Okay, that's the square root of minus 1 times the square root of
Yeah.
25. That's I, that's 5. That's why it's
Okay.
plus 5i, not a minus 5i.
Yeah, yeah.
What's this
And
one?
then we have 7 plus 7i.
Now multiply them together, FOIL them.
We have 21 plus 21i plus, okay, 5 is 35i plus 35i squared.
Now simplify that.
Okay, so we have 21 plus 35 plus 21, that's 56i plus 35i squared.
And simplify that.
We get be
Put the
would
real
that be a negative
real
35?
part
Maybe
first.
okay. So we have to simplify the 35i squared into be a real number, right?
Mm-hmm.
So we'd get it'd be negative 35.
Uh-huh.
So we'd get yeah, I can't do that in my head. Give me a second. 35 negative 35 minus
Not minus.
35.
Not minus.
Not minus.
Plus
It's 14.
it's negative.
Yeah, it's negative 14.
That's the real part. Imaginary part
Okay.
is 56.
Plus 56.
Well, 56.
And that's the answer right there.
Yeah. It's got to be in A
Okay.
plus BI format. That's A plus BI format.
Well, what just happened?
I don't know. Did it not like that answer?
No, the app is just weird sometimes.
Hmm.
Okay, so it's negative 14 plus what?
56i.
Plus 56i.
Mm-hmm.
Yep, that's correct.
Okay.
This one is parentheses negative 2 plus 9i squared. The whole thing's squared, by the way. Like the whole parentheses are.
Oh, I like that.
Yeah, that's what I meant, sorry.
That's okay.
So all we need to do is just FOIL it out
Okay.
with the 2.
Yep.
So can you write it out for me, like the 2
I
parentheses? Thank you. I just need that visual. It helps me out a lot better. So then we have 4. So we have 4 minus 18i. And then we have, minus 18i plus 81i squared.
Simplify.
18 minus 18, that's negative 36. So it's 4 minus 36i plus 81i squared.
Simplify.
And the 81i squared turns into a negative 81.
Mm-hmm.
And so the 81 minus 4 is, hold on, just to make sure I got this right, is 77.
Okay, you've
So we
stated
have
that wrong twice now. It's
oh, did I?
It's not 81 minus 4. It's negative
That's,
81 plus
well, yeah, it's negative 77.
4. Well, it gives you the wrong sign. If you state it the way you stated it, you're going to get
Oh,
77.
yeah.
If you state it correctly, you're going to get minus 77.
Okay.
Okay?
So it's
Now,
negative 77.
with the negative 81, and you're adding 4. There's a plus sign in front of that 4.
Yeah, okay.
It's minus 77 minus 36i.
minus 36i. Okay. Let me double check real quick. Negative 77 minus 36i.
Mm-hmm.
Let's see. Negative 77 minus 36i, right?
Mm-hmm.
Okay. Yep, that's correct. I'm hoping there's some division problems in here.
Yeah, we'll get to one.
It's right here, actually.
Okay.
It's 6 plus I over negative 5 minus 2i.
And again, it's important to remember this is not a division problem. It's a
Yeah.
multiplication problem in disguise. So what do I have to multiply top and bottom by?
What's it called? I know what it.
Conjugate. Well, what is it? You don't need to know the name, actually. So all you need to know is what it is.
Is it plus 5 plus 2i?
Now, the only difference is the middle sign.
The only difference is the middle sign, so is it negative 5 plus 2i?
Yeah.
Okay, over negative.
You don't change the signs of both terms. You just change the middle sign. And
so that is it 6 minus
since I have to multiply the bottom by that, I got to multiply the top by it also. Remember, I can only multiply a fraction by the number 1. That's the number 1. Now, do the bottom first, just so you'll see that this always turns into a real number. What do you get when you do the bottom first? And one way, let me give you an easy tip on how to do the bottom. Multiply that times that, and then subtract that times that. It's as simple as that.
Okay.
What do you get?
So we have 25, right? And then we have a negative 4i squared.
Uh-huh. In other words, you always know that those two middle terms you would have gotten are going to cancel one another. And notice they would. I would end up with 25 minus 10i plus 10i minus 4i squared. These two terms always cancel. So what you end up with is difference of perfect squares.
Okay.
What's that denominator become?
That becomes 25 minus, or plus 4, so that's 29.
Real number, okay? Now let's do the numerator. You got to FOIL the two numerators. Now we're not getting rid of the I in the numerator, but that's fine. You can have an imaginary numerator. You just can't have an imaginary denominator.
Okay. So we'd have negative 30. Yeah, negative 30. And is it FOIL or is it like the bottom one?
No, it's FOIL. Well, the bottom one is FOIL also.
Oh, okay.
It's just that when I FOIL the bottom, the two middle terms disappear. Always.
Okay.
Because I'm multiplying by the conjugate. Well, I'm not multiplying by the conjugate in the top. So my two middle terms are not going to disappear. So you need them. What's the second term?
All right. Then we have 12i. Plus 12i, that is.
That's a plus, right.
Yeah, and then we have negative 5i. And plus 2i squared.
Okay. Simplify that all at once. What's the real part?
The real part would be negative 32.
And what's the imaginary
part? The imaginary part would be 8. It'd be 8i, correct?
It's 12 minus 5.
12 minus 5, so 12 minus 4 is 8, so it'd be 7. I think, right? Am I just saying things?
No, you're right. You're right. Now, that answer is not in A plus BI format. It's the one time you're doing division that you don't end up with A plus BI format directly. You got to convert it. So
let me read what it says real quick.
How do I? Well, just split it into two fractions.
Split it into two fractions.
You got this fraction plus
Okay.
fraction. So what's
So
that?
we have 32 over 29 plus 7i over 29, right?
Negative 32 over 29. Do not drop negative signs.
Yeah, yeah.
Plus 7
7i
over
over 9.
29. And then the I goes there. So that's A. That's B. And there's your I.
Okay, does that simplify out anymore or no?
I don't think so. 29 is a prime number, so there's nothing that divides into 29, and the numerator is not a multiple of 29. So, no, can't simplify that.
Okay. So the answer is negative 32 over 29 plus 7 over 29i.
Uh-huh.
Okay, let me write that out real quick.
Okay.
Let me just double check. So it's negative 32 over 29. Oops. Over 29 plus. Oops. Oh my god, what's going on? What's it doing? No, it's being weird.
Might need parentheses on some of this.
No, that's not what it is. It's just being a dumb site right now.
Okay. Well,
Oh,
I can assure you that's the answer.
yeah. So negative 32 over 29 plus 7 over 29?
Uh-huh. Just like I have it.
I'm just making sure. And then is the I on the end, is it on the 7 or the end of the fraction?
Actually on the end. In other words, B
Okay.
is 7 over 29.
Yeah, that was correct. All right. Yeah, that's all I have for right now.
Okay.
And then I have some more sessions tomorrow with you, so we can probably finish out a couple more tomorrow.
Okay. Yeah,
All right, thank you.
imagine your numbers are a lot easier than people think they are.
They are.
They are.
I
They
agree.
really are. There's not really much to them that makes them complex once you get by addition, subtraction, multiplication, and division. And
Yeah, true.
knowing what to do with I squared. That's key.
All right.
Other than
Well,
that, they're pretty straightforward.
yeah, they are. I appreciate your help. Thank you very much. I appreciate it.
Talk to you tomorrow.